All right, we'll get started. So welcome, thanks for coming. I'm James Ward. I'm a developer evangelist at Heroku. Heroku was acquired by Salesforce.com about a year ago, but we're now a part of Salesforce. So this talk is going to be about deploying Spring and Grails applications on the cloud with Heroku. And I'd love it if you guys ask your questions as I go. So we can make sure that you don't have to remember them all the way to the end. So just feel free at any time to raise your hand and ask questions. So with that, let's get started. So Heroku is really three things. We call it a cloud application platform, but it's really comprised of polyglot. So we support a number of different languages and technologies. Java was just added fairly recently. Ruby support on Heroku is where we started, so that's been around for a while. So a lot of different languages and technologies are supported. It's also a platform as a service, so that means that you can deploy your applications on the cloud, instantly have them up and running on the cloud, available for anyone to use. And we take care of managing everything underneath your application. So this is really the advantage of platform as a service, is that you don't have to deal with managing servers. You don't have to deal with managing databases. All of the services are taken care of for you, and you focus just on your application layer. And then the last part of Heroku is cloud components. We call them Heroku add-ons. And anything that's not core to your application can be provisioned through an add-on. So things like SQL databases, relational databases, NoSQL databases, monitoring and alerting systems. Really anything that is extending beyond the core of your application is an add-on or a cloud service, cloud component. So there's over 1 million applications now running today on Heroku. So that means that really tons of developers have deployed applications on Heroku, both for production use and just for development use or staging environments, that sort of thing. So really a broad variety of things there. So in terms of what Heroku actually is, there's really 5 major pieces of Heroku. There's the instant deployment, being able to push your application up to the cloud. There's the HTTP routing and load balancing. The elastic polyglot runtime, being able to instantly create new nodes that can handle requests or process work in your application. And then there's management and logging, so being able to have full control over how your application is running, see the logs, see everything that's happening behind the scenes on Heroku. And then the last one is the add-ons that I mentioned, the component as a service ecosystem. So I'm going to be going through really all 5 of these. I'm going to tempt fate today and actually try to do some live demos. I'm going to try to start from scratch, build some applications completely from scratch, and then try to deploy those on the cloud. I am using my tethered phone connection, so we'll see how well that works. But yeah, so we'll hopefully do this live. So let's dive into an actual demo here. So I think with this demo, you'll get a better idea of how, as a developer, you can build an application and then run it on the cloud with Heroku. I'm going to start with from scratch, using SpringIO. Has anybody here used SpringIO before? Okay, a couple people. So SpringIO, if you're not familiar with it, it's a rapid application development tool. And what it's doing is it's going to create an easy way for us to build an application that uses Spring and Hibernate and all the typical pieces of a Java web application. So this is really just one example of a type of application that we can deploy on Heroku. It's pretty typical pieces of an application stack, Spring and Hibernate and all those pieces. But it's just an example of one thing that you can deploy on Heroku. Heroku supports a lot of different things. I'll show Grails in a little bit as well. So it's not that you have to do it exactly like I'm going to show you. It's just an example of how you can do it. So let me start out here and create a new directory for my application. I'll call it pets. And then I'm going to run the root shell Ru provides this command line interface, makes it really easy to build up an application. So I go into the Ru shell, and now what I want to do is actually use a script. So there's a demo application that comes with Ru. It's called the Pet Clinic application. And I'm going to use their Pet Clinic Ru script. What that script does is it's really just a bunch of commands that are going to be run against Ru that's going to create my entities, create my controllers, create my views. So all that stuff will be created. You'll see a bunch of stuff fly by, but don't worry. I'm going to go into IntelliJ and then show you the code in IntelliJ as well. So let's do that. Clinic.ru. So now this is creating all the files in this project, all the domain classes and all the views and everything. So that's good. Now, I could run this project as is now, locally, but to run it on Heroku, I want to do a few extra steps. The first thing that I need to do is I need to configure my persistence. Right now, the default is the in-memory database, the HSQL database, and I don't want to do that in my production cloud system. I want to use a real database. Heroku has a lot of different database options, and I'll talk about that in a little bit. But the default database option is Postgres database. So I'm going to tell this Ru application to connect to Postgres, and there's two different steps that I have to do that. So the first one is I'm going to say persistence setup, and then I'm going to tell it that the provider is Hibernate, and then the database is Postgres. So now this will configure my Spring configuration, my JPA configuration, and add a dependency for the Postgres driver, okay? And then the next one that I need to do is actually a plugin for Ru called Heroku. And this will just do a few other changes to this application that will really get it ready to run on the cloud with Heroku. So I'm going to run Heroku setup, and there we go. Okay, so let's now exit out of here and go into IntelliJ. And I'm going to open up this project in IntelliJ so we can see what's actually going on here. So what we'll see is really just a standard Java web application. In my source directory, I've got my Java classes. I have my domain objects. So there's a pet object for my pet clinic. And this is just a JPA bean with some JSR 303 validations on it. It's really pretty typical stuff here in my domain layer. And then I have my controller layer. Ru does a bunch of nice stuff for us, so the controller is pretty thin in this case. So that's good. And then I have my typical Spring configuration, my application context, my database stuff, my persistence XML. I do need to make one change in here. The default of create is kind of a problem when running in production, because what that means is every time I start up an instance of this application, it's going to recreate my schema, and that's probably not what I want in production. So I'm going to just change this to update for now. And then also in this application, we'll see the usual JSPXs here, so like list.jspx for pets, really just a standard Java application. Okay, so that's the layout of this application. Let's open up the Maven build, because I want to show you one important thing in here. So Heroku, it's a platform as a service, but we don't provide an application server for you. What that means is that you actually have to bring your application server with you to Heroku. There's a lot of different ways for how you can bring your application server with you. You can actually just put it into a directory and essentially upload it up to Heroku. But the way that we suggest that you bring your application server with you is to actually specify an application server as a dependency of your application. And there's some benefits to doing it this way. One is that it works well with Heroku. It's an easy way to get that application server up to Heroku. But it also avoids a lot of the issues that we have as Java developers, where the environments that we as developers have on our local machines may not match what we have on production and staging, and may not even match what other developers have. And so this problems that arise from these disparities in application server versioning and configuration can be alleviated by specifying your application server as a dependency. So we think this is generally a good practice. We'd like to see the Java community embrace this sort of mentality more. But let me show you how that's done here. So this is one of the changes that the Heroku plugin for Rue made to my Maven build, was to add in this Maven dependency plugin to Maven and then specify Jetty Runner as an artifact that is now a dependency of this application. And so when I do this Maven build, it will then pull Jetty down with it. And so now I can actually launch this application, this web application with Jetty. So the way that I actually launch it, let me show you. There's a file here called a proc file. And the proc file, probably a little hard to see the text there, but what it's doing is just java minus jar, and then Jetty runner, and then passing it the war file that I want to run. That's it. So that's the way that I actually start up this application server, is just by calling java minus jar. So it makes a really easy way to start the container, start the Jetty container up, get everything up and running, and my application will bootstrap. So the reason why I have this proc file in this directory is that on Heroku, we may not know how to start your application up. With Grails, we know how to start a Grails application, so you don't need a proc file. You can have one if you want and override the defaults, but by default, we know how to start a Grails application. By default, with just a Maven build, we don't know what process to run to actually start up the web process on Heroku. So that's why we need this proc file. So this is really the only thing in this application that is not essentially portable to another cloud vendor. Okay, so we've got this application. It looks good. It looks like it's ready for the cloud. Let me show you one thing before I go on. So one of the other changes that the Heroku plugin for Rue made to this application was that when this application is created on Heroku, Heroku is going to automatically create a Postgres database add-on for this application. And the way that that add-on tells my application about the connection information, the username and password, the connection string, the database to connect to, all that information, they actually set that into an environment variable that then my application reads. And so we had to make a little change to this Spring configuration file to tell it how to use that database URL. So there's, we're pulling in a database URL environment variable into this bean here. This environment variable, on Heroku, it has to be a polyglot style environment variable to specify the connection information. We chose Git because a lot of developers are starting to use that for their source control now. We're really just using it as a replacement for doing SCP or FTP, those sorts of things. And so I'm going to use Git. If you're not using Git for your source control, you can still have a Git repository that contains what you want to push up to Heroku. So you don't have to use Git as source control in order for this to work for you. So in terms of what I'm actually going to push up to Heroku, it's really up to me. I can put anything that I want into this Git repository and push it to Heroku. But what I'm choosing to do for this demo is I'm actually just going to push my source code for my application, my proc file, and my Maven build file. And that's it. No binary assets. The advantage of doing it this way for this demo is that I would probably wait years to upload a WAR file over my tethered wireless connection. So instead of doing that, I'm going to push up my source code, which will be a lot smaller upload. And then when the source code and Maven build get up to Heroku, Heroku will run the Maven build, and then the dependencies, including Jetty, will all download on the cloud, so it'll happen much faster than it would otherwise. So I need to create a Git repository, so I'm going to say git init, and then let's add that proc file, my Maven build file, and the source directory, and then I'll commit them. There we go. So I've got all my files now in the Git repository, they're committed, and now I need to tell Heroku, hey, I want to create an application on the cloud. And the way that we do that today is through the command line. What the command line, Heroku has a command line client, just called Heroku. What it's going to do is actually call the management APIs on Heroku and tell it to create a new application for me. I've already logged in through the command line, the Heroku command line, so it knows who I am. So when I tell Heroku to create a new application for me, it knows who I am, and it'll go and instantiate a new application space for me on Heroku.
So let's try that out, hoping that the internet works. So I'm going to tell Heroku create -s seeder. The -s is for stack. We're telling it to use the seeder stack on Heroku. That's the third generation of Heroku. It's the one that supports Java and Scala and all that good stuff. So let's give it a try. So this will make that API call up to Heroku and create a new application space for me. As I said, there's just the command line interface to those APIs today, but we are also looking at Eclipse plugins and IntelliJ plugins, and we could do Rue plugins to do this. So because it's just calling a management API, we can essentially wrap any type of interface around that. Today it's command line. Okay, cool. So we get a dynamically generated name for my application. I can certainly specify my own application name if I want to. And I get an HTTP endpoint for the application and a GET endpoint for the application. That GET endpoint will end up being added to my Git configuration. So now when I do a Git push, I can push to that GET endpoint. But before we do that, let's go try out this URL in the browser and see how that looks. It might take a second to load. So I haven't actually pushed up my application yet to Heroku. So what we'll see, if it loads hopefully, is just a default page on Heroku. So it won't be anything special yet. There we go. Okay. So now let's actually push up my application up to Heroku. So I'm going to do git push Heroku master. So Heroku is the name for that Git endpoint. Master is the branch of that we're pushing to, the Git branch that we're pushing to, so the master branch. And so when I run this, it might take a minute, depending on the speed of my connection here. So it's only going to have to upload about 100K. So again, should be much faster than uploading the 20 meg WAR file or whatever it is for this application. So when it does this, it'll receive the files through the git push upload. And then Heroku will run the Maven build on this project, assemble all the dependencies, assemble the WAR file, and then it creates what's called a slug file. The slug file is really just everything that my application needs to run. So it's just a Heroku way of creating this file that then we can take this file and deploy it onto a runtime environment for slug files. So we call these runtime environments for slug files, we call them dynos. And a dyno it's kind of a server, but we don't call it a server. We call it a dyno because if we called it a server, then people would think that they have to manage the server, that they have to do security updates on the server. And this is a platform as a service, so we don't call it a server. It's technically a Linux LXC container. It's isolated from all the other Linux LXC containers that Heroku runs. So it's this isolated container. It's a Linux system, but it's one that we manage so that you don't have to deal with system administration. So we take this slug file and we copy it onto a dyno, and then once the dyno is all up and running, we start the process, the web process for this application by looking into the proc file to determine what command to run on the system. Oh, cool, it happened. Okay, there we go. So all that stuff that I just went through just happened. So now if we go back to the browser and hit reload, then once the internet kicks in, we'll see this application up and running on the cloud. So now anybody could use this application. It's automatically now connected to that Postgres database that was configured for this application. And hey, okay, cool. There's our pet clinic running on the cloud. So let's give it a try here. See if we can go add a new pet. Is my battery? Okay. So we'll try this application out and see how it does. There we go. So let's go add in my dog named Wolf. Very exciting. Cool. So this application is all up and running and working. So that's great. So my application is there. It's running on the cloud. But one of the huge benefits of the cloud is the ability to instantly scale an application up or down. So let me show you how we would do that on Heroku. So there's different ways to do it, but the regular way to do it is to, again, use this Heroku command line client and tell Heroku that we want not just one dyno running our application, but let's say we want 5 dynos running our application. So what I'm going to do is say Heroku scale web equals 5. And so now I have one dyno running my application. It's going to start up 4 new dynos, deploy the slug file that it created in the build process onto those 4 dynos, and then start the web process on all 4 of those dynos. So that's, oh, looks like it's gone, cool. So we can use Heroku PS to see what processes I currently have running on Heroku. So automatically on Heroku, we will load balance all the HTTP requests to this application across all 5 dynos, or how many ever dynos are running our application. So those are probably up and going now. So let's go, actually before I go there, let's do Heroku logs minus T. This will output all the logging information. So on Heroku, all of the logging information goes to a central place. So all the standard out from my dynos, and then all of the routing information from Heroku all gets logged to a central location. We can use the command line to see that logging information, or we can also take a feed of that log information and pipe it somewhere else if we want to. So let's go now back to the application and go list all of our pets. And this particular request, it's composed of maybe 20 HTTP requests back to the server. So all 20-ish of those requests are now going to be automatically load balanced across all 5 dynos. So, cool, that worked. Let's go see here in the logs that you can see this PNG request went to Web 2, this GIF request went to Web 4, another one went to Web 5. So you'll see it's automatically scattering these requests across all of my dynos that are up and running. Okay? So Heroku's taking care of the load balancing, but there's a question often about auto scaling. Some platform as a service providers provide the ability to automatically scale an application up and down based on throughput or some other thing. In the base Heroku platform, we actually don't do auto scaling of your application. The reason for that is that we let you run anything on Heroku, which means that you're not constrained in how you build your application, but the trade-off of that is that we don't know how to scale your application. It could be that there's a bottleneck in your database that's actually causing slowdowns, and adding a bunch of new web tier nodes is not going to improve things. It may actually hurt things to add more. And so we don't know how your application needs to scale. So what we do instead is we provide the APIs to get to the information about how many requests per second is my application getting, what's the backlog, what's the wait time in the load balancer. So we provide that information, and then we also provide the API that tells the application to scale. So when I went to the command line and said Heroku scale web equals 5, that's just making a RESTful API call to Heroku. And so what people have done is they've built open source tools and other services that listen to this information coming from Heroku and do auto scaling based on different metrics. But we didn't build that into Heroku because we don't want to have to constrain you in how you build your application. So we left it up to third-party tools to handle that, just because there's so many different ways that people want to do auto scaling. Okay, there's another question that often comes up about the load balancing on Heroku. So often in Java web applications, we use sticky sessions to stick users to specific servers. And then we use session replication to take session information and replicate it across servers for failover or for whatever we may need it for. What we've found from talking to a lot of customers is that most customers do not like this idea of having a stateless web tier. So people are beginning to move to more stateless web tiers as a way to not have to deal with this session replication thing that ultimately doesn't scale very well. And instead, we can go stateless in the web tier, or if we do need state in our web tier, we can move that state to an external system like a relational database. That would be kind of slow, so if we want to use something like a NoSQL database, we can do that. If we want to use a Memcache server or something like that, we can do it that way.
So there's a lot of different ways to do it, but ultimately what we have to do is make the nodes that are handling web requests have the server affinity model. And so that's a much more scalable model, and that's why Heroku doesn't even support sticky sessions today. So from talking to a lot of customers, no one has been able to build a really scalable system with sticky sessions and session replication that we've heard of. So we're definitely looking for feedback on this, but that seems to be the consensus. So for now, we recommend go stateless in your web tier or move your state out to an external system. There's different ways that you can do that. You can go in and code in your application anything that's using session state. You can code it, recode it, and make it use some external data store. Or Jetty and Tomcat both have ways to take your session and actually move it to an external data store without you having to make any code changes. So all you have to do is configure a new session manager that can either be Mongo or Memcache or some other system, and the application server will then transparently do the request to this external system for session information instead of looking for that stuff in memory. So there's a trade-off there, obviously. A network request to like a Memcache service is going to have, even though it's going to be much lighter weight than talking to a relational database, there will be overhead that isn't there when you're talking in memory. I would say that the overhead there is not more than the overhead of session replication. I think it's probably less than the overhead of session replication. But there is going to be overhead there that depending on how much you're using the session, may impact performance. Yeah, question?
How is it done in this demo? Like, are there a separate session on each timer, or is there a single score somewhere? Or?
So my understanding of SpringIO is that it has a pretty stateless web tier approach, that it doesn't use session for anything other than Spring Security does use session state, and so this particular demo doesn't use Spring Security, so I don't have to deal with session state in this particular one. But if I did want to implement Spring Security, that does use session state for basically who the user is. So if I did want to go to Spring Security, I would have to have some way to move that session state out into an external system. So I did a blog post that goes through the details of how you can tell Jetty to move its session state out to MongoDB. It's really not very difficult to do. Tomcat has the same thing as well, so we could do it either way. Yeah, good question. Other questions? Yeah. Yeah, good question. So yeah, we're definitely talking to a lot of different providers right now about setting up Heroku add-ons, and that's definitely some of the stuff that we're looking into. There's add-ons for like RabbitMQ already. There's add-ons for Neo4j. So there's a lot of this stuff already there. We have Memcache. I was just talking to Greg Luck about doing a JSR 107 caching implementation as an add-on. So yeah, it's definitely an expanding area. There's, I think, over 50 add-ons today. If you just go to addons.heroku.com, you'll see them all. But it's a quickly expanding list of add-ons. Yeah, good question. Let me show you how we can manage our add-ons in an application. So if I want to see what add-ons this application has, I can just type Heroku add-ons, and this will make an API call as me, list my add-ons that I have, and you see that I just have this shared database. That's the Postgres database that everyone gets for free with an application. If I want to add a new add-on, like let's say I want to add the Memcache add-on, let me find the name of it. Do add-ons list, and then let's grep for Memcache. So this will list all the add-ons, but then I just want to see the Memcache one there. So most of the add-ons have different levels of service. Most of them provide a free tier of service. So like the shared database 5 meg, that's the free tier of our Postgres database service. And then Memcache provides some different levels here. I think that the free one for Memcache is just 5 megs. So if we do Heroku add-ons :add, and then add the Memcache, and then :5 meg. So this will add the free tier of that Memcache service add-on.
So now this will go out to this service provider that's providing Memcache as a service and provision a new Memcache server for me. And then the way that it gets the information into my application about the Memcache connection information is through these environment variables. So let me show you how we list the environment variables. If we do Heroku config, then we'll see all the environment variables for my application. One of those will be the database URL that got set from the Postgres add-on. And then now we should also see one there for the Memcache information. So maybe. I don't see my Memcache one. Let's try again. So we see my database one, and there we go. Just took a second, but there we go. So this is now 3 environment variables with the information for accessing the Memcache service. So now in my application, if I wanted to take advantage of Memcache, I'd have to configure my application or my container to use this connection information. And there's tons of add-ons. Definitely check them out, addons.heroku.com. One of the really cool ones is New Relic. New Relic is a performance monitoring and alerting system. So it'll actually instrument your application and then give you information on how long each method call is taking. You can set up alerts and say if this method call takes 300 milliseconds or more, then send me a page. So a really great add-on there. They have a great free tier as well. Okay, so let's jump on to something else here. So just to recap these five different pieces that I've kind of showed through the demo. There's instant deployment through git push, and there's the load balancing that happens automatically. There's the elastic polyglot runtime, the ability to scale up. One thing I didn't talk about there was you can also do non-web processes. So I was just showing a web process today, but if you have a worker process that needs to be running all the time, processing some work, you can do worker processes as well. You scale them in the same way, you define them in the proc file the same way. And then management and logging, that's the REST APIs that Heroku provides, the command line interface to those today. We also have a Java library that interfaces with those REST APIs, and then the logging system as well. And then the Heroku add-ons. So the great thing for developers on Heroku is that it's essentially free for developers to use and get started with. If you just go to Heroku.com and sign up, you can start creating and deploying applications. You don't even have to give a credit card to do that. And every application that you create, so every time you do that Heroku create, that application can run on one dyno for free every month. So the Heroku model is that until you start scaling beyond that one dyno, you don't need to pay Heroku any money. There are add-ons that have commercial tiers, but a lot of them have free tiers. So for a lot of things, you can just use Heroku for free, and really, it's only when you have to scale or increase your level of add-ons and that sort of thing that you have to start paying anything for Heroku. This application that I just scaled to 5 dynos, I would essentially get billed. If I left all 5 of those dynos running for a month, I would get billed for essentially 4 dynos because I'm getting the one for free. Okay. So great way to get started with Heroku is you go to java.herokuapp.com, and all you have to do is you select an application to start with. So you can do a SpringIO one. I need to add the Groovy one. Haven't done that one yet, or the Grails one. Haven't done that one yet. But so you can select an application template, put in your email address, which is just your Heroku account. Click go, and actually a copy of that application will be deployed on Heroku just for you, and then you can start making changes to it. There's instructions on how to get started and go from there. Okay, so let's talk about, let's make sure I covered everything. Oh, one other thing, you can also see every time you do a git push to Heroku that successfully completes a build, every time you change an add-on, every time you change an environment variable, what Heroku does is it creates a new version of the slug file, and we keep all the slug files around so that you can roll back to previous versions very easily. So you can see the releases with Heroku releases. You can roll back to previous releases just with Heroku rollback. You can also run one-off processes. You can say Heroku run and run any command that you want on a fresh dyno. And then you can also, there's an add-on for doing scheduled jobs as well. So if you want to schedule a process to run once an hour or once a day, you can use the Heroku scheduler add-on for that. Okay. One thing to point out, you can connect to any database from Heroku. So the default one that comes with every application is a Postgres database. That's just the freebie. But there are add-on providers for MySQL, for Amazon Web Services provides Oracle and MySQL. You can use database.com, a salesforce.com database. So lots of different options for what database to connect to. If you already have your own database up and running somewhere, you can connect to that as well. So lots of different options. Okay, so let's do some Grails stuff. So again, I'm going to try to tempt fate and start from scratch with the Grails app. But before I go on to Grails, any questions about anything that you've seen so far? Yeah?
Well, the databases, do you use a Dino as well, or are you using a Dino when you port
Good question. So all of the add-ons that provide a service are actually external to the dynos. So the dynos are just this web processing tier or potentially worker tier in your application. And then all of the databases that you would connect to are all external to the dynos. So in my example here, I had one database running and all 5 dynos were connecting to that one database that was external to all of them. Yeah, so that's really the recommended approach. A dyno is really just for running a process that's either doing worker background stuff or web processing.
So if I see that I have a bottleneck in one of the databases, how do I port? How do I scale?
So that would depend on the database provider. So our shared database, that's just the freebie, it doesn't provide a lot of flexibility for how you scale that database. But providers like MongoDB, they provide a huge pool of Mongo servers, and they're going to deal with the scalability of that system for you. Whereas for relational databases, we have an enterprise-level Postgres service that does provide things like read slaves that you can set up and do your reads from a read slave so that you can deal with scalability that way. Yep, okay. So let's create a Grails app real quick and deploy that on Heroku. Let's do Grails, create app, and call it GB. How many people here are using Grails? Cool. All right. I'm pretty new to Grails. Been enjoying it. It's a great web framework. So let's go in here, and I'm going to do Grails create domain class. If I start typing things wrong, I'm new to Grails, so tell me that I'm doing the wrong command or something like that. So let's create a new domain class bar. I want to do something a little more exciting than a hello world. So let's create our domain class there. And then let's go edit that class. Okay, so this bar is going to have a name. And now I can do Grails generate all, and for gb.bar. So this will generate my controllers and views and all that good stuff. So this is going to be a typical Grails application. Heroku has specific support for Grails. So the example that I showed before, what we were really using on Heroku was the Maven build part of Heroku. So this one, when I push it up to Heroku, it's going to be, Heroku knows how to handle Grails applications as a special case. So let's test this out in the browser, make sure everything works. And then we'll get it ready for Heroku and deploy it. So, ready, set, go. Let's go to localhost 8080/GB. GB. There we go. Okay, here's my very exciting little bar application. Let's go add in a new bar. Hello. Okay, great. So that's all working locally. So in order to now run this on Heroku, again, I need to do a few things to configure the data source part of this application. I could certainly run on Heroku with an embedded database, but that's probably not what I want to do. So let's go back here, and there's 2 plugins for Grails that I need to add that handle this stuff for me. So the first one is just the Heroku one. So I'm going to say install plugin Heroku. So I'll install the Heroku plugin into this application, and then we'll install the cloud support plugin as well. So those, what the Heroku plugin, part of what it's doing is it will automatically see if I have that database URL environment variable and use that for the connection information instead of using the in-memory one. So there's a few different ways to set this up, but this is kind of the easy way here. So let's add the cloud support as well. I don't totally know what the cloud support one does, know that it's needed. Maybe somebody here knows what the cloud support one does. Cloud support?
It's shared between Cloud Foundry and Heroku plugins.
Okay, cool. So it's just some...
For rewiring the data source.
Okay, cool. Okay, so now, one other quick thing. I need to go tell my application that it depends on the Postgres JDBC driver. So let's go into my build config here and go add in a runtime dependency for Postgres QL colon Postgres QL, and it's 9.1.901-1.jdbc4. Did I get that right? Okay, cool. Okay, so now my application is configured to use the Heroku Postgres database. So the next thing to do is to get it ready for the Git upload. So I can use the Grails integrate with Git. So now this creates a git ignore file for me and writes it there. So now I can do my git init and then stat us. So now I can do my git add, and I'm going to add, I don't want to add everything. I'm just going to do a few things here. And web app, and then commit. Okay, so now my application is ready to be uploaded to Heroku. So let's do Heroku create minus sseeder. We're going to create a whole new application for this, this one. So this, hang with me, internet connection. Cool, we got cold winter. I was up in Stockholm for JFocus, and that was a cold winter up there. It's always fun to see what names we get. Okay, now let's do our git push Heroku master. So you notice I didn't need to create a proc file like I did for the SpringIO one because we know what a Grails application looks like, so we know what process to start. So now, once these files upload again, I'm not uploading a WAR file. You could upload a WAR file if you want. You could put it into a Git repository, but we would be here for a few years waiting for the upload to happen, where in this case, just 100K of upload, so that's pretty quick. So now Heroku will run essentially the Grails build on this project, create the slug file like before, deploy that slug file onto a dyno, and then we'll be up and running. Might take a minute depending on network. Go, network, go. Any questions about the Grails stuff? Well, hopefully that finishes. So 2.01 I believe is also supported. I don't know how we clarify what version to use, but there's got to be somewhere where it says the version in a config file, right? Maybe? Anywhere it says in Groovy config?
Yeah, well, sorry, in the application.
Yeah, yeah.
Application.properties.
Okay, so in application.properties it'll have the Grails version. So that's how we decide what version to use. I don't think we go all the way back in terms of versions. I think we have to use the latest 1.x version as well, because that's when we started working on the Grails support for Heroku. So I think it's that latest 1.x plus is what's officially supported. Okay, cool. So we are up and running. Let's go check it out. So cold winter, be very exciting here. Let's see, have a new application for creating bars in the cloud. I've always wanted to go to a cloud bar. But yeah. Any other questions about the Grails support? Okay. Cool, there it is. Let's go. Make sure it works. Make sure it's connecting to the database. Create. Okay, I'll be around, so if you have any other questions, feel free to ask me. But hopefully that was useful for you. Thanks for coming.